Hello everyone, welcome to a brand new episode of Professor Argan. Whenever we heard about laser, we often visualize an intense bright monochromatic light and what more we know about it. So let's discuss about that, what a laser is. As is also has an importance in different analytical instruments. Do you know that the word laser is an abbreviated form? And if you know it, write it down in the comment box. Otherwise, don't worry, right at the end of this video, I will let you know. In 1916, Albert Einstein discovered the physical principle responsible for the amplification of light. Those are stimulated emission, population inversion, and optical resonance. And simultaneously, those three principles are responsible for the intense monochromatic laser beam. Stimulated emission occurs when a photon strikes an excited atom or molecule and thereby causes the atom or molecule to emit the photon prematurely, which is possible when the impinging photon has the exactly same energy of the storage photon in the excited atom or molecule. To achieve this phenomena of stimulated emission, population inversion must take place, that is, presence of more atom or molecule at excited state than in the ground state of the lasing material, and which is possible for a multi-level system. And finally, optical resonance is achieved by placing the lasing material in a cavity situated between a pair of parallel plane mirrors which has the spacing of integral multiple of the desired wavelength. Sometimes crystals of lithium iodide or potassium dihydrogen phosphate may be used to double of the multiplicity. If still you have some confusion in understanding this mechanism, don't worry, I am going to explain it with an example. To carry out the three principles in a laser operation, a multi-level system is required. One of the very popular laser source is He-Ni laser or helium-neon laser. In this, at first, a helium atom is excited by an electrical discharge to a long-lived triplet state, which only can lose energy by collision with another atom with comparable energy. One excited state of neon lies only 313 cm inverse below the excited helium state. The excited state of neon has relatively longer lifetime before it spontaneously decays to the ground state with the emission of photons at 1153 and 632.8 nanometer. Thus, presence of larger neon atoms available at excited state than in ground state leads to population inversion. A spontaneous emission of a single photon at either of these wavelengths can trigger a cascade of similar photon by the process of stimulated emission. For optical resonance, gold mirrors are used in case of He-Ni laser. In helium-neon laser line, 632.8 nanometer is favorably located in the spectrum where the least amount of fluorescence problem appear in routine analysis. Likewise, argon chromium is also ideal for many experiments which provide intense lines at 488, 514, 568 and 647 nanometer respectively. In carbon dioxide laser, the energy difference between vibrational rotational levels are used and nitrogen is also mixed to get the population inversion. Ruby laser is also well known, in which chromium is embedded in the aluminum oxide crystal. The output frequency of tunable dye laser, which use a liquid laser medium like rhodomin 6G, can also be varied over a short frequency range. In that case, prisms and gratings are used for fine-tuning the dye lasers. And definitely we will know the utilization of laser in Raman instrumentation, planar laser-induced fluorescence, tomoscopic laser spectroscope, single molecular analysis, etc. Also, it has immense utilization in agricultural science, archaeological finding, material processing like welding, drilling, surface treatment, alloying, etc. If you know any other application or any kind of instruments which involve laser as a radiation source, please comment on the comment box. The laser beams are also used in surgery instead of a conventional scalpel. The infrared beam from the carbon dioxide laser is strongly absorbed by water molecule in the tissue. It produces a rapid evaporation of these molecules, consequently cutting the tissue, which causes limited damage to blood vessel and adjacent tissues. And I have not forgotten to share that laser is the acronym of light amplification by stimulated emission of radiation. And now you also know the reason behind it. If you find this video informative, please do like, share and subscribe. See you soon with another interesting episode. Till then, bye bye.